Good day, students. You are welcome to Top Form Education Associates. My name is Olubayo Marilyn Kendi, your mathematics teacher. And today we are going to be looking at the topic volume of solids. Volume of solids. Now, the lesson objectives. By the end of this lesson, you should be able to use the appropriate units for volume of solids and capacity of a container. Also, you should be able to use formula to calculate the volume of a cube and cuboid. You should be able to calculate the capacity of a simple container, and you should be able to calculate the volume and the surface area of a prism. The instructional materials we'll be using for today's lesson is the Essential Mathematics for Junior Secondary School Book 1 and the New General Mathematics for Junior Secondary School Book 1. Now, straight away, let's go to volume of cuboids. Volume of cuboids. The volume of a solid is a measure of the amount of space it occupies. Okay? The volume of a solid is a measure of the amount of space it can occupy. A solid object is also called a 3D object, meaning a three-dimensional object. Okay? The cube is used as the basic shape to estimate the volume of a solid. The cube is the basic shape for estimating the volume of a solid. Therefore, volume is measured in cubic units. Cubic units. The common units, the common cubic units are cubic millimeters. This is millimeters in cube. That is cubic millimeters. Cubic centimeters. Okay, that is this. And cubic meters. Cubic meters. Cubic millimeters, cubic centimeters, and cubic meters. A cube of an edge 1 centimeter has a volume of 1 cubic centimeters. I hope you understand that. A cube with an edge of 1 centimeter has a volume of 1 cubic centimeters. This is a symbol for cubic centimeters, cm raised to power 3. Now, using formula for finding the volumes of a cuboid, we're going to learn how to use formula to find the volume of a cuboid. Now, a typical example of a solid is a cuboid. Okay, a very good example of a solid is a cuboid. A cuboid is also called a rectangular prism. Okay, another name for a cuboid is a rectangular prism. It has length, width, also known as the breadth, and height. Okay, also known as thickness. So whenever you see a question with thickness, you know we're talking about height. And when you see a question with breadth, you know we're talking about the width. Now, the volume of a cuboid is given by length times width times height. Okay? Remember, this can also be breadth in some scenarios. So you can have it as length times breadth times height. But here, we're going to make use of width. So the formula for calculating volume of cuboid or a rectangular prism is length times width times height. This is the abbreviations of this. Now, for example, to find the volume of this cuboid, this is the length, this is the width or the breadth, and this is the height or the thickness. So what do? We multiply all together. Okay, so it's going to be 6 times 4 times 2 to give us 48 centimeters. Therefore, the volume of this cuboid or rectangular prism is 48 centimeters. Now, in the above formula, which is given here, we know that length times width is area. Okay, the formula for calculating area, we all know that is length times width, where length times width will give us area, where A is the base area of the cuboid. Okay, whenever we see A, know that we're talking about base area. Okay, A represents base area. So, therefore, volume of a cuboid can also be base area times height. So, in a case where you are given the base area, instead of being given the length and the width, you are given base area. You know that they are talking about length and width. So, you can also find volume using base area times height. Okay, so this is the abbreviation volume, which is V, equals to A times H. A representing a base area, okay, and H representing height or thickness. Now, also, the face of a cuboid is a rectangle. Okay, if you look at this cuboid, you will see that its face is a rectangle. So V is equal to area of any face times the thickness of the face. Okay? The area of this face times the thickness is the same thing, meaning volume is equal to A times H. That's area times height. Remember we said height is also called thickness. Now let's go to volume of cubes. When all the edges of a cuboid are equal, okay, it is called a cube. When we have a cuboid having equal edges, okay, they are called cubes. Now remember we said cuboids have rectangular shapes, but cube have equal shapes, meaning they have a square, they have square edges. Okay, so when all the edges of a cuboid are equal, they are called cube. If one edge is 1 unit long, then volume of a cube is equal to length times height times width, which we've established that are equal. So we can say the volume of a cube is L times L times L, or L raised to power 3, or L cubed. Do you understand? The volume of a cube is L cubed. Why? Because a cube has equal edges. Okay, so the length, the height, and the width or the thickness are all the same. Okay, they are all equal. So a cube of an edge 4 centimeter will have a volume of 64 centimeter cube. How do we get 64 centimeter cube? 4 times 4 times 4. Okay, I hope you understand. Now, we can use the above formula to find the edge of a cube when the volume is given. Okay, if you have a question that you are given the volume, okay, and you're asked to find the edge of the cube. Very simple, because the edges are all equal, we'll have the formula as L cubed equal to V. Okay, then you can have your L as L equal to the cube root. Okay, whenever you see this, it's called cube root. Cube root V. Okay, so you can get your L by using this formula, cube root V. Now, for example, a cube of volume 27 centimeters has an edge of dash. We are asked to find the edge. Okay? Now, to find the edge, remember the formula we are given, L equals to cube root V. Okay, and we said the volume is 27. So, we are going to look for the cube root of 27. And the cube root of 27 is what? 3. Okay, it's simplified out here. Okay, 27 is 3 times 3 times 3. So the cube root of 27 is 3. So therefore, a cube of volume 27 centimeter cube will have an edge of 3 centimeters. 3 centimeters. Now let's take some more examples. Now, number 1. Calculate the volume of the rectangular tank of a rectangular tank with dimensions 25 centimeters by 20 centimeters by 10 centimeters shown in this diagram. Okay, we're given the dimensions as height of 10 centimeters, width, okay, width 20 centimeters, and the length 25 centimeters. Now, if you look at this shape, you see that this is a cuboid. Okay, a cuboid. A cuboid is a rectangular prism. Now, the volume is length times width times height. So, simply, you multiply all together as given in the formula. Okay, the formula for finding volume is length times width times height. And when you multiply all of them together, you have 5,000 centimeter cubes. Okay, 5,000 centimeter cubes. So, take note of the units. Take note of the units. Volume is always expressed in centimeter cubes. So, the volume of this cuboid with these given dimensions is 5,000 centimeter cubes. Number 2, a cuboid is 12 centimeter long and 8 centimeter wide. If the volume of the cuboid is 624 centimeters, okay, find the height of the cuboid. If the volume of the cuboid is 624 centimeters, okay, find the height of the cuboid. Now, solution. Substituting these into the formula. Remember, the formula for volume is length times width times height. And we're given the volume as 624 centimeter cubes. Now, we're asked to find the height of the cuboid. Now, we have length as 12 centimeters. We have width as 8 centimeters, but we don't know the height. Now, let's substitute the values into the formula. Volume is 624 centimeters, length 12, and width 8. Now, when we multiply 12 times 8, we have 96. Okay? So to get h, we divide both sides by 96. And when you do that, you have the height as 6.5 centimeters. Okay? 6.5 centimeters. So a cuboid with a height of 12 centimeters and a width of 8 centimeters will have a height of 6.5 centimeters if the volume is 624 centimeters cube. Now, number 3. A container in the shape of a cube is used to store a liquid. Pay attention. A container in the shape of a cube is used to store a liquid. One edge of the container is 25 centimeters long. Okay? Now, the depth of the liquid in the container is 15 centimeters as shown in this diagram. Okay? This is the depth of the liquid. Now, this is the container. This is the length of the container. This is 25 centimeters. And this is the length of the depth of the liquid. Okay? They said it is 15 centimeters. Now, A, we are asked to calculate the volume of the liquid in the container. Okay, that's the volume of this liquid having this depth. And B, we're asked to calculate the volume of the container that was not filled with the liquid. Now, C, express the volume of the container not filled with liquid as a percentage of the full container. Okay, now this is a very big question. Now, we're asked to express the volume of the container not filled with liquid as a percentage of the full container. Solution. We're going to take this step by step. First of all, we are going to look for the base area of the container. Okay? We're going to look for the base area of the container. And remember we said base area, to look for base area is the length times the width. Okay? The formula for base area is length times width. So, we have the length as 25 centimeters, okay, and the width as also 25 centimeters. And when you multiply that together, you have 625 centimeters as the base area. Now, the depth of the liquid in the container is given to us as 15 centimeters, okay, from the question. The depth of the liquid in the container is 15 centimeters. Now, to look for the volume of the liquid in the container, okay, we are going to multiply the base area of the container multiplied by the depth of the liquid. Okay, we'll multiply we are going to multiply the base area and the depth of the liquid. Now, when you do the multiplication, that's 625 multiplied by 15, we have 9,375 centimeters. Okay, so we've gotten the base area. Okay, we've gotten the volume of the liquid in the container. Now, let's look for the volume of the cube. Remember, we've said that a cube has equal length. Okay, a cube always have equal length. So we said the formula for looking for the volume of a cube is L cubed. That is length raised to power 3. So the length is 25. So when we multiply it 3 times, that is, when we take the cube, when we multiply it times 3, we are going to have 15,625 centimeter cube. Therefore, the volume of the cube is 15,625 centimeters cubed. Now, let us look for the volume of the container that is not filled with the liquid. Okay? Let us look for the volume that is not filled with liquid. To do that, we simply subtract. Since we have the volume of the container, okay, and we have since we have the volume of the cube and we have the volume of the liquid in the container, all we have to do is to subtract. We've looked for the volume of the liquid in the container. We use the depth, okay, the depth of the liquid in the container to look for the volume, and we've also gotten the volume of the cube, that's the volume of the container. Now, to look for the volume not filled, we are going to subtract the volume of the liquid in the container from the volume of the cube. And when we do the subtraction, we have the answer as 6,250 centimeter cubed. Therefore, the volume of the container not filled with the liquid is 6,250 centimeter cubed. I hope you understand. Now, number 5, okay, the next example, number 5, we're asked to calculate the volume of a coin box that measures 14 centimeters by 10 centimeters, 5 millimeters by 8 centimeters, 4 millimeters. Okay, now, the solution. Now, I want you to take notes and pay close attention to the units. You will see that we have millimeters and we have centimeters in one question. So, what we are going to do, we are going to make all the units equal. Okay? We'll make all the units equal. And we all know that 1 centimeter is equal to 10 millimeters. So, in converting, we have 10 centimeters, 5 millimeters as 10.5 centimeters, and 8 centimeters, 4 millimeters as 8.4 centimeters. How did we do it? We simply divided by 10. We divided by 10. Now, the volume, this is a very simple question. The volume is length times width times height. So when you do all the multiplication, we have 1,234.8 centimeters cubed. Okay, so the volume of the coin box that measures with the given dimension is 1,234.8 centimeters. Let's look at the units of volume and capacity. Okay, let's look at the units of volume and capacity. So whenever we are solving, we'll know how to impute the units in our workings. Now, 1 millimeters make 100 centimeters. 1 millimeter is equal to 100 centimeters. Therefore, 1 meter equals 100 centimeters. 1 meter equals 100 centimeters. Therefore, 1 meter cube will be 100 times 100 times 100, which will give us 10 raised to the power 6 centimeters cubed. Okay? 10 raised to the power 6 centimeters. How did we get the 10 raised to the power 6? Just count the zeros very simply. 1, 2, 3, 4, 5, 6. Okay? So we have 10 raised to the power 6 centimeters cubed. Now, B, 1 meter will make 1,000 millimeters. 1 meter is equal to 1,000 millimeters, or 1,000 millimeter is equal to 1 meter. So in volume, 1 meter cubed is 1,000 times 1,000 times 1,000, which is 10 raised to the power 9 centimeter cubed. Okay? In the same light, 1 kilometer will give us 1,000 meters. 1 kilometer make 1,000 meters. 1,000 meters make 1 kilometer. So 1 kilometer cubed in volume will be 1,000 times 1,000 times 1,000, which will give us 10 raised to the power 9 centimeters cubed. Now, finally, 1 centimeter will make 10 millimeters, or 10 millimeters will make 1 centimeter. So in volume, 1 centimeter cubed will give us 10 multiplied by 10 multiplied by 10 millimeter cubed. So therefore, we have it as 1,000 millimeter cubed. So 1 centimeter cubed is the same thing as 1,000 millimeter cubed. So the capacity of a container is the volume of liquid or gas it can hold when full. Okay? So the capacity of a container can be defined as the volume of liquid or gas it can hold when it is full. Capacity simply means the ability of a container to hold, or the ability of a container to hold liquid when it is full. The volume of the liquid that the container has ability to hold. The volume of the liquid the container has ability to hold. That is simply capacity. The basic unit of capacity is the metric system of units in liters. Okay? So whenever you're solving a question concerning capacity, you know that you have to leave your answers in liters. Now, 1 liter is 100 centiliters. 1 liter is also 100 milliliters. 1 liter equals 100 milliliters, and 1 liter equals 100 centiliters. 1 kiloliter is equal to 1,000 liter. Take note of this unit. It will be very, very helpful in our calculations. 1 kiloliter makes 1,000 liters. Now, the relationship between the units of capacity and the units of volume are given by 1 milliliter makes 1 centimeter cubed. Okay? 1 liter is equal to 1,000 centimeter cubed. 1 liter makes 1,000 centimeter cubed. 1,000 liters make 1 meter cubed. 1 meter cubed. Take note of the units. 1 kiloliter will make 1 million centimeter cubed or 1 meter cubed. Okay? 1 kiloliter makes 1 million centimeter cubed or 1 meter cubed. Now let's take some examples. Number 1, calculate the capacity of an oil tank measuring 4 meters by 120 centimeters in A liters, B centimeter cubed. Okay, I want you to take note of the units. You will see that we have meters and centimeters in a question. So the first thing to do here is to convert all to the same unit. Okay, all the measurements have to be in the same unit. So we're going to convert this centimeters to meter. And in converting centimeter to meter, we know that we should divide by 100. So 120 centimeters will give us 1.2 meters. Therefore, to calculate for the volume of the oil tank, we use the normal formula for calculating volume, which is length times width times height. And when we take the multiplication, when we do the multiplication, we have the volume of the oil tank as 5.76 meter cubed. Okay, 5.76 meter cubed. So the first question here, we're asked to convert it to liters. Since we've gotten it in volume, let's convert it to liters. Now, 1 meter cubed gives us 1,000 liters. Okay, from previous slide we said 1 meter cube will give us 1,000 liters. Therefore, 5.7 meter cubed will give us 5.76 times 1,000. Therefore, we have 5,760 liters. Okay, so therefore the capacity of this oil tank will be 5,760 liters. Now we also have to look for the capacity of this oil tank in centimeter cubed. Okay, now we said 1 liter is equal to 1,000 centimeter cubed. Okay, 1 meter equals 1,000 centimeter cubed. 1 meter cubed is 1,000 liters, while 1 liter is 1,000 centimeter cubed. Now, 5,760 liters will be multiplied by 1,000. Okay? It will be 5,760 multiplied by 1,000. We have 5,760,000 centimeter cubed. Okay? This is the capacity of this oil tank in centimeter cubed.